Hello, Internet. Welcome, welcome, good afternoon, and welcome to another NL Math Man Math Help stream. Hope social distancing is finding you well. Having a glass of water here. And I insist that this is water, all right? No matter what the real Albert Einstein in chat might imply, I am not drinking straight vodka. All right, look at this bottle. Look at this bottle. That is not a liquor bottle. Absolutely not. No, that is only for water. It's only ever been water. Okay. So it's nice glass. It's made of glass. Right? You hear that? Hear that twitch? Right? Glass is what? So it's a lot of things. It's sand. But glass is non-reactive, right? Inert glass. So it doesn't put any taste on your water, right? If I kept it in a plastic bottle, eventually I might get leaching. I might start to taste the plastic on my water, Twitch chat. I might. But as long as it's in glass, hey, you're good to go, right? So it doesn't matter that it may or may not at one point have contained gin. You know, it might or might not have. But, you know, as far as I'm concerned, it's a water bottle and it's always been a water bottle, right? So therefore, what I'm drinking must logically be water. Okay. Yeah, we got a wonderful picture here today. Look at that. Oh my goodness, little muddy buddies, the little buddies. Oh my goodness, look how fuzzy they are. Little Smoky over here. Little Smoky buddy, and little Flurry. Yes, they needed a bath after that one. It's quite a romp they were having that day. I believe this was, where was this? This was outside at one of the trails just north of Gander, I think. I think that's where this was. Anyway, can't recall off the top of my head. Where's the tea that I run out? Oh, no, I got some more tea actually. Mine's it's a little bit cool right now. I have a drop of tea left. I'm down to just normal Tetley now because I managed to get some tea bags delivered on my Coleman's delivery, but it's just plain old orange pico, which I know is kind of like Earl Grey. It's got the bergamot, whatever it's called, the oil of bergamot. Got all that left out. Hear about tigers getting corona. Apparently dogs can't, but cats can catch it. Yeah, I mean, I did hear, Brittany, I did hear, I saw the article that you're talking about the Bronx Zoo and a tiger testing positive for coronavirus. Now, coronaviruses have been in animals for a long time. Like we've known about that for quite a long time. I mean, that's how COVID-19 is theorized to have passed to humans. I believe the current theory is from bats via pangolins in a wet market in Hunan, I think Hunan seafood market in Wuhan, China. Anyway, I don't believe they've shown cats to be a vector for transmitting the disease. But if they do prove to be one, I imagine that'll be it'll be significant news. But as of now, I think cats have not shown to be a vector. Although yes, a tiger did test positive for having it. The real question is feline or cat, human transmission possible? But anyway, not going to derail my math stream too much with coronavirus talk right at the right at the start. Let's do a bit of mathematics first. Maybe we'll go over that after. And yes, good afternoon, Esther, as well. See you there in chat. Thanks for dropping in. So today, like my sheet says, let me flip on over here to the working display. Here we go. Whoop. Oh, we still see Smokey in the corner. That's good, little buddy. So today the topics will include, like it says here, percentiles of central tendency. So that is what I'm going to start off with first. So Esther, that is one of the ones that you asked about. Now, like I mentioned, I'm not going to do, I think question one is maybe fairly similar to the stuff that you've already been doing. So how about you try question one on your own, I would recommend, and then see how far you get, because question one is a good review, because this stem and leaf plot, we've done those. Three measures of central tendency. That just means mean, median, and mode. Right, so we've done those. Actually, I'll write that down for you. I'll write that down so you have that on the notes when I give it to you. Maybe that's part of the confusion there. But what central tendency means is those three. All right, so this is going to be, what is this? Math 3102A Unit 2. And yeah, so central tendency is mean, median, and mode. Right? Now those are super important different topics to learn, right? Which is which, what do those mean? Right? But we went over that a fair bit, and that one is in the notes as well. So for now, I'm gonna move past those. If you do still have issues with those, please let me know specifically, right? But I'm going to go on and I'm going to focus on question 2 today because the other one you mentioned, question 2, is a really good one because um, that one moves on sort of to the percentiles topic, which is the one that we're on now. Uh, it asked me a couple things for your tutor. Um, yeah, so you can email me or so if you need anything like that. Yeah, just let me know if you want to, I don't know, for me to talk to you about whatever after the stream is over, you can. Okay. So then for question 2, since 2010, most Canadian provinces have passed laws prohibiting cell phone use while driving. That's true. That's true. In one of the English courses, we forced students to read a Rex Murphy bit about it, which is it's kind of funny actually. It's one of it's he's a little bit on point with the snark, right? Um, So researchers monitor how long it takes drivers to react to a flashing light when driving normally, while attempting to text, or while talking on a cell phone. Here are some of the reaction times in seconds, right? So a list of numbers. The researchers find that the reaction time for normal driving are in the 25th percentile or lower. Okay, so while normal driving, people react faster. That makes sense. What reaction times are in this range? Okay, so that's a good question. This is a really well worded question, actually, because it's the sort of situation where we would use upper and lower quartiles, or we would use box and whisker plots, actually. I don't know why this course doesn't teach box and whisker plots. To my money, that's the point. That's the point of doing um, lower and upper quartiles, is so you can then start drawing box and whiskers. But anyway, let's carry on here with 2A. So in order to solve this, we're going to need to have all the numbers written out. So I'm just going to write them out as they're written on the page here now, because there's too many of them. 4.6, 2, 1.5, 3.5, 3.8, 0.9, 4.8, 0.5, 4.5, 5.1. I'm going to read them all aloud. It's riveting. That's some good television, isn't it? That's great. It's great radio. Great radio. Just listening to a guy read out some numbers. 4.2, 3.5, 3.4. Just did a Bob Duca voice all of a sudden. I've got hypertolerance to lactose. I have Lou Gehrig's disease, Lou Barlow's disease, and Lucy Lou flu. Anyway, that's a really obscure comedy bang bang bit there for you guys. Actually, it was Comedy Death Ray. It was Comedy Death Ray still at that time, wasn't it, Scott Ackerman? Scott Ackerman's watching, which he's not. There you go. I corrected myself. Um, so I'm going to do a stem and leaf plot. We're not told that we have to do a stem and leaf plot, but I'm going to go ahead and do one anyway, just because this is what you were asked to do in question 1 up there, create a stem and leaf plot. So I'm going to do one for the question 2 data set instead. So it'll be a good example of how you do the question 1 ones, right? But so our stems are going to be our first digits. So here are our first digits. We've got zeros, we've got ones, we've got twos, we've got threes, and we got fours. So 0, 1, 2, 3, and 4 we've got. I'm going to try to put these in order right away. So what I'm going to do now is I'm going to go through and I'm going to cross these ones off of this list whenever I put one in, right? So we've got a 0.5 and a 0.9. That is all the zeros. So a 5 and a 9. For ones, we've got 1.5, we've got 1.3. Looks like it's it. So a 3 and a 5. For 2, we've got a 2.0. So that's definitely going to be the first one. We've got a 2.1. And that's it. For threes, then, looks like we've got a few for threes. We've got a 4, 2 5s, and an 8. Yep, looks like it. 4, 5, 5, and 8. Oh, we also have 5s. For 4s, now we have a 6, a 5, a 7, and a 2, and an 8. 2, 5, 6, 7, and 8. See, that's right, right? And now for 5s, we have a 5.1 and a 5.2. Okay? So this is how you would do a stem and leaf mostly, but we also need a key. And this one now, this is a really good example to show you why you need a key. Because without this key, I wouldn't know that there's actually a decimal in between the stem and the leaf, right? Because it looks like, normally if you saw 0 here and 5 here, you would think that answer is 5. But it's totally valid to do a stem and leaf plot where there is a decimal in the middle. It's actually 0.5 or 0.9 or 1.3. That's totally fine. Just your key down here has got to be there, and it's got to represent that. Okay, so we're asked for the 25th percentile or lower. So to find out the 25th percentile, first we're going to need the mean. So to find 25th or 75th percentile, you should first find the mean, which is also the 50th percentile. Oh, sorry, not mean, median. My mistake. There we go. See, gotta stick to keeping it accurate. So to find 25th or 75th percentile, you should first find the median, or the 50th percentile. So what's the 50th percentile going to be here? Well, how many data points do we have? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have n equals 17. N is the number. N is the number of data points. So n is equal to 17. So we know that the median is going to be 17 plus 1 over 2, where it's going to be 18 over 2, or the 9th number in order. So now let's do that in a different color so that we can see over here. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So the median equals 30, or sorry, we're going to say 35, 3.5. 3.5 is our median, and that is the 50th percentile. Right? So now let's do this next part in another color. The 25th percentile is the median of the lower half of the numbers. Right? So, well, how do we find the lower half of the numbers? Oh, I need to zoom out a touch, do I? Sort of scrolling off my page here. So 25th percentile is the median of the lower half of the numbers. Well, what lower half of the numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them, right? So if there's 8 numbers, it's going to be 8 plus 1 over 2 is going to tell us which number we're dealing with, which is going to be 9 over 2, which is going to be 4.5. So 1, 2, 3, 4, 5. It's going to be the one between, so 4 is 15 and 5 is 20. So we're going to have 15 plus 20 over 2, which is going to work out to be 17.5. Okay? Now, I've seen books, textbooks and stuff do this differently sometimes. There is one little wrinkle that, from what I've seen, books and assignments and stuff aren't 100% consistent on, and that is if you count the median when you're doing this. Now, I don't, as you notice. I leave the median out, and I count just these other 9. But if we counted the median as well, Q1 would end up being 20, right? But I was always told to leave the median out and just to look at the bottom half. Now, if your book comes back and says, oh, the answer is 20, not 17.5, then you'll know why, right? If you're on a test or an assignment, I would prefer you to take just the lower numbers, so not counting the median. Because if you count the median, you end up counting it twice, right? You end up counting the median in the lower half and the median in the upper half, right? But if I saw you doing that, if I saw you counting the median on the test, I'm not going to mark you totally wrong. You're still going to get like almost all the marks for it, or maybe all of them, depending on what your what your text shows you. But anyway, I am doing not counting that. So the green numbers that we're dealing with, sort of this set over here. So this is the set that we're looking at to find if it's find what the lower quartile is, or Q1. So what reaction times are in this range? Okay, reaction times for normal driving are in the 25th percentile or lower. So 25th percentile or lower. So values 25th percentile or lower are going to be 0 0.5, 0 0.9, 1.3, and 1.5. Okay, reaction times in the 75th percentile or higher are recorded for drivers who are attempting to text. What reaction times are in this range? Okay, so then B is going to have quite a lot less working than A did. Because for B then, I'll do that in red, we're just going to go ahead and count the upper half of the numbers. Right, so it's going to be these 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be this set here. So we still have 8 numbers plus 1 number over 2 gives us 4.5. Right, so we're going to count 1, 2, 3, 4. So it's going to be between 46 and 4.6 and 4.7. So I'll have 4.6 plus 4.7. So it's going to be those two. Actually, yeah, I'll underline the ones from that as well, just so when you're reviewing the notes, this might be a bit clearer thanks to my color coding. Hopefully that helps. This over 2, so of course going to be right in between those. So it's going to be, it's not going to be a 6, a 4.65, like so. Right? So values 75th percentile or higher are going to be all the values that are 4.65 or more. So it's going to be 4.7, 4.8, 5.1, and 5.2. There, like that. Okay, and just to show you then, say we did have a, say we did do a box and whisker plot. Normally we would do a box and whisker plot over a number line, right? But the way it would look, actually, you know what? We don't do these in this course, so maybe I'll leave that out. Although it is a really good lesson, and I am still surprised that they don't go on and do box and whiskers in this one. I did do box and whiskers. Yeah, I'm positive I did in the occupational health and safety program. I taught sort of like stats and like understanding math and stats for them. And box and whisker plots are fairly practical because you do see them used a lot, and they are based on this exact stuff. It's a visual representation of how clumped the numbers are by using Q1, Q2, and Q3 and the min and the max. But anyway, so that is 2A and B. What's 2C telling us to do? Reaction times of people talking on a cell phone are between the 25th and 75th. According to this research, what are drivers probably doing if they have a reaction time of 4 seconds? Okay, so for C then, 4S, 4S is between. Actually, no, I will draw out a box and whisker. Actually, look at that. Look at that. The box and whisker will actually help us with this question. My goodness, how prescient. Okay. I'm not going to do it over a number line though, because I don't have any graph paper here. We're sort of making do, right? Scuffed a little. So let's draw the median in here. So the median is going to be, we already know the median is 3.5, so that's right here in the middle. So we label these guys, right? This one here is 4.65. That's the upper quartile. So this is Q2, this is Q3, and this is Q1. Q2 is also known as the median. Q1 is going to be here, and that's oh, right. My goodness. I've carried on this and this. So that shouldn't be the decimal there. The decimal should be there. Yes. My goodness. My goodness. Nobody see Twitch, avert your eyes. Nobody see the teacher putting the decimal in the wrong spot. 1.75 over here. And I'll fill in our min and our max just to give a show of doing a fully fledged box and whisker plot. So this is called box and whisker. Box and whiskers. But now what we can do is I can go ahead, instead of writing it over here, 4s's is blank, whatever, I can start sticking them in. So 4, what values is 4 going to fall between? Well, 4s is going to be here, right? Because it's between 3.5 and 4.65. What else do we have? 18 seconds. Holy moly. 18 seconds is going to be way out past here. 18 seconds. If it takes, Twitch chat, if it takes you 18 seconds to respond to something while driving, yeah, I mean, you're probably you're in an accident already. Like you're already in a mashup before you realize that you need to respond to it. 1 second. Okay, so 1 second is going to be down here. 1s is there. 5.5. So 5.5 is still here. I didn't put that 18, of course, in perspective because that's like way out to lunch. What else have we got? 12.8 seconds. So 12.8s is out here as well. So we know from the way the question is written that all the ones between here and here, so these values are people that are what, driving safely. Those ones are driving safely. So we know that the person whose response time was 1 second was driving safely and not doing anything else. This set here, the whole box, right from Q1 on down to Q3, this whole set is talking on phone, right? There like that. And then we were told that this full set out here, from here over, let me try to put a nice little squiggle here. This was, oh, this some texting, right? Now you wouldn't normally draw the brackets like I'm doing here. This is a little bit messed. But you can see from the way I've organized this and drawn out the plot that the person who, if someone has a reaction time of 1 second, what were they probably doing? Well, they were probably driving safely. If someone had a reaction time of 4 seconds, that's between Q1 and Q3. So that person was probably talking on the phone because from the question, it tells us that the people that were between Q1 and Q3 were most likely talking on the phone. Over here, then, the upper quartile, or this is actually like these three are all way past the upper quartile. Like they left the upper quartile beyond ages ago, right? But those people are probably texting. Okay? So that now I've used the absolute entirety of the sheet. There we go. That's Unit 2, Question 2 then in the notes. So Esther, I hope that has helped a bit. Now again, you won't need to know how to draw out a box and whisker plot. I do find them to be quite useful. But all it is this is the min, this is the max, Q1, Q2, and Q3. Right? But this is how you would do these ones, and this is also how you do the first part of question 1, the stem and leaf plot. And then the other ones, we're asking for the 3 measures of central tendency in question 1. That's these guys, mean, median, and mode. I've got loads and loads and loads of practice work on those ones if you want it, let me tell you. No, people, yeah, frequently want extra work on those. So yeah, if you want some more drills and practice and stuff, I got that for days. Okay. 3102A. That was good. So now, what else do we have? Yes, Renetta, I believe you mentioned some irregular shapes. I am going to, let's see. Actually, Renetta, your stuff and no, I will go over yours now. Yes, I will. Yep. Okay, here we go. So, areas of compound shapes. These aren't the exact ones in your book, Renetta, but I am going to go over a few of these ones just to show you some examples. Now, I'm not going to go over the hard ones. They're like number 2. It's not really hard. It's just different. This is different than what you've been used to so far. Let me move my screen a little bit. There we go. So let's see. What am I going to start off with? Let's start off with an easy one. Let's start off with this one here. Right. So this is. Let me know on practice sheets. Yeah, yeah, please do. Yeah, if you want any more practice sheets, it's no trouble. I can get you some. I mean, you know how it is when I'm in class, right? I mean, in class I can get you practice sheets within, I don't know, 15, 20 minutes of asking for it normally. Here it's going to be a bit longer, obviously, because everything is a bit slower when it's done over the internet, and you can't like look at me just to see if I'm dealing with a student or not. Like you never know, right? So yeah, stuff does take longer over the internet, of course. But this is area and perimeter of irregular shapes. Instead of irregular shapes, you'll see it sometimes called compound shapes. I believe it might actually be, yeah, it's called, see here, it's called compound shapes there too. So it's just worth knowing that irregular shapes and compound shapes sort of mean the same thing. So for 1A then, because I don't have printout of this one here, I'm just going to quickly draw out the shape. Okay, there we go. So we've got, this is 4 cm this way, 4 cm this way as well. This is 6 cm, and this is 8 cm. Now, they don't tell us any angles and stuff. That is one of my peeves about this one, because we're not 100% sure that this is a 90-degree angle here, or that this is also 4. So, but you do have to assume that it is 4 in order to solve the question. So I'm going to denote it as we would normally with lines there like that to show that these two are the same. I can even, in fact, indicate that that one is the same as well. We would also denote that the top and the bottom are the same by using a 2 notches there and a 2 notches there. And in this case, we are also going to need to know that this one here is the same as this one here. So I'll use a 3 notch on both of those guys just to make it 100% clear. Like if it was a test or something and not just a random sheet that I kind of made up, it would have these markings on there. But now we can go through and we can solve this in 2 different ways. The first way I'll do in, actually I'll do the first one in green so you can see how I'm splitting it. What I'm going to do now is I'm going to go through and split it into different shapes. Let's say I split it into, I don't know, say I split it across here this way and across here this way. So now I have 3 rectangles, right? So I have this one here like that, this one here like that, and then this one here like that, right? So I'll call this T, or the area of the top. Well, the top rectangle, we know, how can we figure out the size of this guy? Well, we know that this side is 6 because this one over here is 6. So one of the sides is going to be 6. And what's the other one going to be? Right? This one's 6. What's this? Well, we don't know yet, but we do have now that I've marked it, clearly indicated that these two are the same, we do have enough info to tell. Because we know that from here to here is 4 centimeters. So that means what's left over between here and here has got to also be 4. Right? It's also 4 because this is 8. 8 subtract 4 is 4. So we have 4 centimeters left over to split between these two guys, which means we know this one's got to be 2. And this has also got to be 2. So the area of the top rectangle is simply just going to be 6 times 2, which is 12 centimeters squared. Okay, easy peasy. So then we've got, I'll call this area the middle one. The area of the middle one is going to be this guy over here, right? So we know that it's 4 in this direction, so I'll put down my 4. And what's it across here? Well, since we know this is 6 and this is 4, we know that's got to be 2. So it's going to be 4 times 2 is 8 cubic, or sorry, not cubic, 8 square centimeters, right? Then the area of the bottom, or of the bottom one, this one is actually the same as the top one. That's going to be 6 times 2, which is 12. So the area total is going to be 12 plus 8, which is going to be 32 centimeters squared. Right? So that is one way to tackle problems like this. Another way to tackle it would be to imagine that this was actually a full shape, right? So this part here, this red part, is what was cut out. But sort of imagine that this was still there, right? So then the area of the hole, right? The hole shape with a W. I could do area of hole with a W and area of hole with an H. That'd be a bit mean. Anyway, the area of the hole shape is going to be 6 times 8, which is going to be 48 square centimeters, right? And the area of the gap, or the part that's left out, is going to be 4 this way and 4 this way. So the area of the gap is going to be 4 times 4, which is 16 centimeters squared. And the area of the shape is going to be 48 minus 16, because we're taking away the missing part, which is going to be, not a 4, it's going to be 32 centimeters squared again. Okay? So there are 2 different ways that we can handle this guy, but it's going to get us to the same answer in the end. Now I know on my sheet there it just says find the area, but I'm going to find the perimeter as well. I'll show you the perimeter down here below, right? But all the perimeter is just all the outside sides added together, right? So we know we've got this 8 over here on the left. We've got, I'm just going to go around it clockwise, starting over here at like the 9 o'clock position. We've got 6 on the top. We've got 2 right there. Right? We've got 4 here. We've got 4 here. Another 4 here. Another 2 here. And another 6 there. So now we're just going to go ahead and add those guys together. 8 plus 6 is 14, 2 is 16, 4 is 20, 24, 28, 30, 36. So that's 36 centimeters. They're not centimeters squared. This one's just straight up centimeters because it's a measure of distance around the outside. Okay? Oh yes, and Ashley, if you were watching these ones as well, I know you might have been waiting to see some stuff about the work you did today. It's a little bit similar because there is one question on the stuff that you did that's like this. So I'm going to go on to yours next because that'll be a good transition from the ones that Renetta needed. Okay, so now, that wasn't 1A, that was just 1. It doesn't really matter. This is not a sheet that anyone's going to see. Let's do a fancy one. Let's do a fancy one. All right, let's do this guy. Yeah, let's do question 9 here. The inscribed circle. No, I'll do that one next. I'll do 3. I'll do 3 in total off this sheet. That should be enough, then I think, to reiterate how you do these guys. So this is going to be question 8 over here. This one has what looks to be, is it equilateral? No, maybe it's not. Anyway, it has a triangle on top, like so, and then a rectangle down below. All right, tough to get that one to dry out exactly right. There's a lot of concerns there, but that's fine. We're told now that this distance is 6 cm, and this distance is 6 cm. I know it doesn't look much like it, right? Because this distance is definitely not half this full size. But like I said, right, don't look at how the diagram is shaped. Look at what the numbers on it are saying. Because teachers are meanies, and sometimes we will intentionally make it look different than the numbers that we're telling you it is, just to make sure that you can't pull out a ruler and figure out the question that way. So it's 18 centimeters top to bottom, there like that. Okay? Oh yes, and it's also 12 cm up this way. So we've got 2 different shapes here now. This one is not really reasonable to do via the subtraction method, so there's only really one way that you're going to get this one. So I'm going to go ahead and, tell you what, I'm going to go ahead and fill this on across here. Then I'm going to fill this one in with blue notches, right? So that's going to be the area of the square. It's going to equal just 12 times 12. So it's going to be 144 square centimeters, or a gross. A gross, right? A great number. I love that it's called a gross. The next part is going to be up here. So that's the triangle. So the area of the triangle, well, we know the area of a triangle is half the base times the height, right? Well, what's the base of this triangle going to be? Well, it's the distance all the way across the bottom here. So it's 6 plus 12 plus 6, or 24. So it's a half times 24 times the height, which is 18. So that's going to be 12 times 18, which will be 180 plus 36, so 216. 216 square centimeters. Let's make 100% sure that I'm doing that math correctly. 216, yep, plus 144, 360. So now, do this, return to the black ink. For this one, area of total is equal to 360 centimeters squared. Just like that. Now we can go ahead and find the perimeter for this guy. I'm not going to show you that one right now, just because the perimeter here involves using the Pythagorean theorem, which is totally a valid type of question. You're going to see ones like that where you have to find the perimeter of a triangle by having the interior measurements, the height, but I'm not going to overload you with too many different things at once now. I'll just let you get to that when the book introduces it to you. But it's not going to be much longer. You're going to see those soon. The next one I'm going to do, which is one like you have seen, like right now, is this inscribed circle. All right, so these ones are going to be totally fair game for a test or an assignment or anything like that. It's a good question too, because it combines a few of the things that we've been doing. Right now, avert your eyes, Twitch chat. I'm going to do another freehand circle. My word in heaven, that is not a circle. That is not even an oblate spheroid. That is at best like a. I mean, like the hen that laid that egg, you would send it back to hen school and be like, you guys, you gotta go work on the shape of your egg, man. It's not even, it's too bumpy and I don't know. Anyway, it wasn't even meant to be an egg. It was meant to be a circle. And I'm not an art teacher, okay? I never once claimed to be an art teacher. So we're going to need to have two things here, right? We're going to need the area of the square, which is the outside. Then we're going to need the area of the circle, which is the inside. So the area of the square, well, how are we going to get that? Well, we know it's 14 cm by 14 cm, right? So it's just going to be 14 times 14, which is going to be, I don't even know what 14 squared is off the top of my head, 196. I should know that one. 196 centimeters squared, right? But then how are we going to find the area of this monstrosity here in the center? Well, we do know the radius of that is 7 centimeters, so assuming that it is indeed a circle, the area is going to be pi times radius squared, which is going to be pi times 7 squared, which is going to be 49 pi's, which is going to be exactly 147. What? It's not. Why is it not? That's 153.9. I'll just say 153.9. I'm going to keep making references to that one Simpsons joke where the guy yells out pi is exactly 3 and the whole room shuts up. I'm gonna keep making references to that joke, and it's entirely for my own amusement. It's not because anybody else is ever gonna get the joke. Sorry, Twitch chat, but you know, you getting the joke is secondary toward me giggling to myself about making a mathematics Simpsons reference. 196 minus 153.9. Right, so the shaded area, we'll do this in red. So the area shaded is going to equal 196 minus 153.9, which is going to equal 42.1 square centimeters. There we go. Okay, so that's a bit more examples on area and perimeter of irregular shapes. So Renetta, I hope that that helped with the, if you're still on that topic. And Ashley, like I said, will lead us neatly into the next topic, which is a few ones that I wanted to go over for you based on the work that you did this morning. So, let's see, this is now Math 1102A, Unit 2. Okay, so let me scroll on up there. There's a few of these ones on here that I want to get to, but thankfully, these ones are fairly quick. Let's see here. Number 7. Yeah, number 7's an okay question. What is the circumference of the nearest tenth of a centimeter of a circle with diameter? And I have to zoom out so you guys can see that it says diameter. With diameter 8.4 centimeters. Let me slide my window over a touch. There we go. Perfect. Okay. So, question 7. Circumference to the nearest tenth of a centimeter, diameter 8.4. Okay, great. So we know that circumference is equal to pi times diameter. That's all we got to do here. So circumference is just equal to pi times 8.4. Right? So we bring up our calculator. 8.4 times pi. Don't even need to put in the time sign if you don't want to. My calculator is saying 26.4. And look, it's right there. C equals 26.4. So that is answer B. B is the answer there for 7. All right, but that's just a real quick review for some of these questions to show you sort of the way that you would go over these ones. Now, 8 is asking for the girth. The girth to the nearest tenth of a centimeter of the figure. Now, I've been over this before. Girth is sort of like the area around the end of the figure, right? Okay, now the girth is the perimeter of the end of a 3-dimensional shape. Right? It's a bit of an odd term to hear come up in math. We don't talk about girthy shapes a whole lot in these math courses. And strangely enough, this is the only course that we use that uses this terminology. So it's totally normal to have not, you know, maybe slip your mind sometimes what it actually means in this context. But all it means is the perimeter of the end of the shape, right? And we always have to use the narrow end. Like I said before, you don't get to cheat, you don't get extra credit. You get to pick which side it is. So it's going to be this one down here, right? So the perimeter of that is just going to be perimeter is equal to 5.2 times 2, because there's a 5.2 on the top and a 5.2 on the bottom, plus 2.5 times 2. So that's going to become then 10.4 plus 5, which is going to be 15.4, right? Which is answer A. B was there, A was there. Okay. So that's those ones. Let's see, I wanted to mention just really quickly question 10, and then I've got a few ones that are maybe a little bit more substantial, but still these will be fairly quick, these questions that I'm going over here in this unit. So a bulletin board measures 7 feet by 4 feet. Helen is asked to put a border around the edge of the bulletin board. What is the perimeter of the bulletin board in yards and feet? Now, it's freaking imperial system. My goodness, at least they didn't ask us to do it in inches. So 7 feet by 4 feet. So what sort of the situation is it? Well, let's draw this guy out. Let me grab my ruler, or my triangle, or my square. I'm not going to tell that story again, but I mean, right? That ain't no square. So it's going to be 7 feet by 4 feet. So 7 feet that way, 4 feet that way. And of course, then we know this rectangular, 7 feet this way, another 4 feet this way. So once we put a border around the edge of it, what is the perimeter in yards and feet? Well, the perimeter in feet, perimeter is going to be 7 times 2 plus 4 times 2, which is going to be 14 plus 8, which is going to be 22 feet. So then all we got to do is convert 22 feet into a combination of yards and feet. Well, how do we do that? Right, well, we know that 1 yard equals 3 feet because that's in the same measurement system. Those are both imperial. So what we can do now is we can divide 22 over 3. But one way we can think about it, when we do 22 over 3, right, if we just took that and did it in the calculator, 22 over 3, oh, excuse me, I accidentally pressed second function there. 22 over 3, 7.33, right? Does that mean 7 yards, 3 feet? I mean, it's there. It's one of the answers, right? 7 yards, 3 feet is what this looks like, but no, it's not. This is not 7 yards, 3 feet, though it may look that way. If it were metric, we could do that, because metric is all powers of 10, which is one reason metric is a lot easier. Imperial, however, is not. Well, what we got to do here is we have to do this division sort of like we were doing the division in the prerequisite courses, like the Math 2012 or whatever it was that introduces 2013, that introduces fraction division. So we're going to treat this like a fraction. What's the biggest number that we can take out? Well, we can take out 7. Right? 7 is the nearest whole number that we can get, and we can see that from doing our division. But we're not going to leave it as a decimal after. We are going to put our 7 down, but now we're going to subtract 7 threes from this 22. Well, what is 7 threes? Well, 7 times 3 is 21. 22 minus 21 is, of course, 1. So this is going to be 7 and 1 over 3 yards, right? Which, and since there's 3, we call that's the same as 7 yard 1 foot. Okay? And that is answer C then. 7 yards, 1 foot. All right? So I'll write down for imperial. Use mixed numbers, not decimals. This is something to remember. For imperial measurements, you should use mixed numbers and not decimals. The one redeeming factor of the imperial system is that basically it's a good avenue for teaching arithmetic with fractions. Like people who learned how to measure things by, sixteenths and eighths of an inch definitely are probably better at fractions than average than people that simply learned to use centimeters. But it is still a big hurdle to get over at the first point. And all of aircraft are measured in imperial because so much of it is manufactured in the States. This is what I'm told by people who work in aircraft for a living. Work on aircraft for a living, I should say. Anyway, I'm going to scroll on down. I'm going to look at question 12. Okay, so question 12 is a one, Renetta, that is like what I was just doing on that one for you there. So you might benefit from going over this guy a little bit as well. So it tells us Dustin is installing baseboard in the bedroom shown. What's the perimeter of the room in feet? Now, actually, I believe when you did this one, there was only an issue with one small part of it. Excuse me for 1 second. I'm going to mute my mic. All right, welcome back. Didn't need to hear that foghorn going off. Okay. I'm glad. I'm glad. I'm very glad. By the way, I'm very glad that sneezing is apparently not a symptom of COVID-19 because boy, oh boy, some I got nasal allergies and some mornings I'll sneeze like I don't sneeze every morning, but some days it'll be like 50 times, like not even exaggeration. But thankfully, thankfully, sneezing is not one of the symptoms. So don't worry about catching COVID over my internet stream. I mean, there's other reasons not to worry about that, but you know, that's one of the reasons. So what is the perimeter of the room in feet? Well, to determine the perimeter, we're going to have to figure out all the measures that we don't currently know. So I'm going to go ahead and draw this guy out. Got a song stuck in my head that I was listening to last night. I keep being tempted to play songs on my stream, like at the opening, but I know that Twitch will mute VODs sometimes if you're playing copyrighted music. I mean, it makes sense because you know streamers don't tend to go out and get permission from the artists or the publishers to play the music and all that. And I really don't want my VODs muted because you know linking people to the VODs is a major part of how I do the pedagogy for this stream. Right, that's a major part of the teaching I'm doing is the VOD integration. So you know, poor old NL Math Man, poor old Peter is going to have to keep the stream music free. Although I do have a lot of the music downloaded from Twitch's very nice complimentary uh, royalty-free music library. So maybe I'll stick some of that in at the beginning sometime. Royalty it's a good resource. There's some decent stuff in there too, although not quite enough. Like I I had a Hearthstone stream years ago, and first I started trying to play only the uncopyrighted music, the stuff that Twitch recommends, and like I don't know, I found like 30 or 40 songs that were okay that I liked like the vibe of, I guess. But yeah, like it's 40 songs on loop. Sounds like a lot first, but it's not. It's not really a lot. No, it's like three album, well, four albums. It's like four albums of music. You get old. It gets old listening to the same four albums over and over. Anyway, so the way that we are going to determine the perimeter of this shape is by finding all the different measures that we don't currently know. We know this one is 15, which means this one over here has also got to be 15. We know this is 20 across the top. This is 4 here, and this is 6 here. So we know that there's 10 left over here. This one is 7. Now we're not actually told that these are right angles. So we don't actually technically, it's very, very technically, we don't have enough information to determine that this is 7 feet. But you're supposed to know that, right? If they gave us, say, a right angle here and a right angle here and like a right angle here, we would know that it was 7. Or if they gave us like the notch and the notch, we would know. But in the absence of any angles, we actually don't know because it could be slanted a bit, right? It could be down like that or something like that. We don't actually know. So if you gave me don't actually know for the answer in this one for that reason, maybe I would consider still giving you the marks. Maybe. But anyway, the perimeter here is just going to be adding all these guys together. So it's going to be, I'm going to start at the top and go clockwise. 20 plus 15 plus 6 plus 7 plus 10 plus 7 plus 4 plus 15. That is going to be 35, 41, 48, 58, 65, 69, 70, no, 84. 84 foots. 84 foots. All right. How much baseboard is needed in yards? Well, that's easy. You ever watch Cowboy Bebop? No, it wasn't Cowboy Bebop. It was Trigun, I think. Yeah, one of those classic anime. I haven't watched a whole lot of anime, but I have watched those. And like they refer to distance in yards, Y-A-R-Z. I don't know why. Why couldn't they just call it yards? They had to call it yards. Anyway, 84 divided by 3. Hey, look at that, 28. Spot on. So we know that 1 yard equals 3 feet. So 84 feet. Now I'll show you. This will be this will be a little preview of some of the stuff I'll get onto on question 16, which I'm going to get to there now in a bit. But it's 84 feet. We can call that multiplied by 1 yard per 3 feet. We can think of it this way. Then the feet are going to cancel with feet. We're going to be left with 84 divided by 3 for the number of yards. And as we saw over here, 84 divided by 3 is 28. So it's going to leave us 28 yards. Okay, so part B for 12 is going to be 28 yards. Now what's part C? Part C says, if each piece of baseboard is sold in 10-foot lengths, how many pieces will Dustin need to buy? Well, we don't need to use yards now, right? Because we're back to feet again. So 10-foot lengths, well, we've got 84 feet. 84 feet, and we're going to divide it by 10, right? Because that's what we're doing. We're breaking it into groups of 10. How many groups of 10 do we have? Well, it's going to be 8.4. So I can say then Dustin needs to buy 9 pieces. Pieces of baseboard. There we go. Because he's not going to buy 8.4, right? The store is unlikely to sell him 8.4. If you wrote down 8.4, I'm not going to mark it wrong, right? But just know that for full marks for the full question, you say Dustin needs to buy 9. Okay, that's question 12 done. I'm going to do part of question 15 and part of question 16. And then Ashley, that'll be a good review of your Math 1102A. So this is a continuation. Math 1102A. Okay, and it is still Unit 2. So we're looking at now question 15B. Scroll on down here. Tell you what, maybe I guess I'll probably have to do the full thing and not just the B part. So a triathlon is a race that involves swimming, running, and cycling. That's literally true. An upcoming Ironman triathlon is described below. Swimming, cycling, and running. Holy fish moly, running 42 kilometers. Yeah. Anyway, I feel impressed after I run for 24 minutes at a stretch. I don't do no 42 kilometers, let me tell you. In total, how many kilometers will the athletes have to complete? Okay, well that's pretty straightforward. So 15A is just going to be adding these things together. So it's going to be 3.8 plus 112.5 plus 42. It's going to equal what? 3.8 plus 112.5 plus 42 is going to equal 158.3. 158.3 kilometers. Wow. Sam is from Boston, wants to compete in the triathlon. In order to train properly, he needs the distance in miles. How much is the total distance in miles? Oh, okay. Well then, Sam, if that is your real name. Uncle Sam. That's what it is. I knew it. Uncle Sam is from Boston. He needs it in miles, right? So now you're going to have to break out your conversion sheet, right? What we're going to use is 1.6 kilometers per mile. That's on your conversion sheet, and that's the conversion factor that we have, right? So it's 1.6 over 1.6 kilometers per every 1 mile. We can equally say, if this is true, like I showed you before, we can flip this guy around. We can say there's 1 mile per every 1.6 kilometers. We could read that as 1 mile per 1.6 kilometers. Right? And that's just the way that we would think of this math written out. Right? Why am I doing that? Why am I writing it this way? Well, I know I showed you cross multiply before for these ones, but I do think, like I mentioned a few weeks back in my streams, that keeping your conversion factor with the units in it can honestly be an easier way to do these a lot of the time. So what we end up with is 158.3 kilometers multiplied by 1 mile per every 1.6 kilometers, right? Once we multiply these guys, we're going to have kilometers on top and kilometers on bottom, which is going to cancel. And that's going to let us know that miles are left over. One reason why this is really, really useful is because it prevents us from um, using the wrong conversion factor. Because here now, once I multiply these, I'm going to get 1 point, sorry, 58.3 over 1.6, and it's going to be left with just miles for my units. And I know that miles are what I'm trying to get, right? So if I go through and just do that out, it's going to be that number divided by 1.6, and we're going to get 98.9. And that, of course, makes sense in context, right? Because we know that a mile is longer than a kilometer. So we should always have a smaller number of miles than we had of kilometers. Now, another reason why this is good is because, well, excuse me, imagine that you use this conversion factor and you try to do that. How would you know that you were doing something wrong? Well, one way you could know that you were doing something wrong so this is an incorrect example here. So I'm writing it in red and putting this here so you don't like. They say if you teach a student something wrong, you had to teach it to them right 10 times to make up for the fact that you taught it to them wrong once. It's kind of true. So I'm not teaching you the wrong way. I'm just sort of showing you an example of how this method is more resilient to mistakes. Right? 158.3 kilometers. Say I use this. Say I use that as my conversion factor, and I was trying to multiply it by 1.6 over 1, right? Because there's 1.6 kilometers per every 1 mile. Now, by leaving in the units, we can realize that we're making a mistake. I mean, we can also realize that we're making a mistake because we'll get a bigger number, and we know that it's not going to be a bigger number. But look what happens if I follow through with the units here. We have kilometers times kilometers on top, so we have kilometers squared, and on bottom we have miles. Kilometers squared per mile. Is it the units we were supposed to get? No, no, it's not. No, it's nonsense. Kilometers squared per mile. What does that even mean? It's foolish, right? Like there's real world application of that is doesn't make any sense, right? So that's one way that we can know by doing this method that we did it correctly. It's because our units properly canceled and we ended up with miles in the end. Here, our kilometers didn't cancel and our miles stuck around, so we ended up with this sort of nonsensical mess over here. So I'm just going to go through and cross all this guy out. I'll leave it clear enough that you can maybe see what happened there. That's one way that we can use sort of our algebra in order to let us know if we're doing something wrong while we're doing it. And on a test situation, for example, that can be really, really useful, is to be able to have different ways to check and see if what you did was right. Now, question 16. Oh, actually, I know you asked specifically about question 18, but I do have something written up for you about question 18. Your only mistake in question 18, actually, you had that one almost right. You're beating yourself up for no reason. See, you think that you're doing something wrong, but you weren't. Everything you did for this question was right, except you missed it. You just forgot that this was the height over here. They already gave you the height, right? So you didn't actually need to do anything to find it. So you got like, I don't know, 3 out of 4, or 3.5 out of 4, whatever it is on that one. So question 16, I would like to take a quick glance at, and I'm going to look at question 16. I'll do the lot of them. I'll do the lot of question 16, I think, and that'll be a good way to clue up this one. Then, Brittany, I will be able to switch over to the Prism Math Purple topics that you wanted. Those, I think, you had questions on 4 different pages of Prism Math Purple, so I'm going to work down through those as well. That should nicely take us up to our hour and a half, hour and 45 or so. So 16a. 16a is 82 centimeters equals some number of inches. So we have 82 cm. And we know that our conversion factor, there's 1 inch per every 2.54 centimeters. Right? Now, actually, you did some of these ones. You did most of these ones right. So but I'm still going to go through all of these just to show you this sort of working that we're doing. Now centimeters are going to cancel with centimeters, and we're going to be left with 82 divided by 2.54, right? And then we're going to have 82 divided by 2.54, 32.3. 32.3 inches. All right, easy. For B then, we're going to keep on chugging away. I'm going to do some of the same stuff. 60 miles, and we're converting it to kilometers, right? Now the same as up above here. Remember we converted that, but I want to pick the one. I want to pick the one of these two where miles is on bottom, right? Taking the one where miles is on bottom is going to let me cancel my miles. So I'm going to have 1.6 kilometers per every mile. I keep having false sneeze. I really feel like I'm going to sneeze switch chat. I feel like it, and then I move to go mute, and then it's like, okay, we missed it. We missed it this time. And that infuriating feeling where you're like, you kind of got to sneeze, and you almost go to sneeze, and then you don't. Oh, Twitch chat, I tell you. Anyway, 1.6 kilometers per every 1 mile. I'm going to take that. Miles are going to cancel with miles. I'm going to be left with 60 times 1.6. I'll use an X here just to show you. 60 times 1.6, which is going to be 96. Yeah, look at that. 96. 96 kilometers. There you go. Question C then. We've got yards to, is it yards to meters? All right, so, oh, okay. Let me take a quick glance at the formula sheet that you got for that unit. I can't recall off the top of my head what formulas we give you in that one. So just bear with me a quick second here. I'm going to go in and grab that one. So the formula sheet that you get is this guy here. So that one you get, let's see, you get yards to inches. We're converting, what was it that we were converting in this one? Yards to meters. Okay, so we need to start off with yards. What have we got? We don't have a yards to meters. Oh, we've got yards squared. Oh, that's unit 3 formula sheet. My mistake. My goodness, Twitch chat. Yeah, just go back to looking at the pretty little puppies for a second. Let me pull it out. Conversion chart unit 2. That should be it. Yeah, there we go. There we go. Okay, so this tells us what we're working with here. So we're going from meters to yards. Do we have? Oh, we do have. We have a 1 yard per every 0.9 meters right here. Right? You see that one? That's the one there. So what we have is, let's see, we are converting 65 yards, and we have 0.9 m per 1 yard. Now, how did I get this 0.9 over 1 from the conversion factor that you were given? Right? Well, it's just because I moved it across. You see, we've got 0.9 m and 1 yard here. If I move this yard over, it would be divide, so you'd have 0.9 m divided by 1 yard. But it's not so important to know the division by as it is to know what it translates into. Because I think what it translates into in words, in this case, this is a rare example of a case where reading out the math in words kind of actually makes more sense. So what we're saying here is that there's 0.9 meters per every 1 yard, which makes sense, right? Because 90 centimeters is a yard roughly, 0.9 meters per every 1 yard. So we just go ahead, we multiply those, the yards are going to cancel. We're going to left with 65 times 0.9, which is 65 minus 6.5, which should be 58.5. Yes, 58.5 meters. There we go. Okay, we're almost there. We've just got one more guy for these ones. So this is going to be part D. Now let me bounce back over to this activity. Oh, oh ho 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 ho. Oh, what a noodle boiler. 93 cm, and we're turning it to DAM. What the heck? What the heck is DAM? Well, now this one's a bit mean. This is a bit mean, Twitch, because the first three were converting between imperial and metric. This one here is converting between metric and metric. So here now, we're actually not going to use this conversion chart. No, sir, we're not. We're going to use this one. This guy. This little guy. Right? And remember, DAM. So DAM is right here. Right? And centimeters are down here. So it says divide by 10 for each step we're going up. Well, how many steps are we going up? We're going up 1, 2, 3. So this is going to be 93, and we're going to divide that by 10 times 10 times 10, because we're going up 3 steps. 3 steps means 3 tens, and it's not divide by 10 in that it's 30. You're not dividing by 30. You're dividing by 10 times 10 times 10. 3 tens multiplied together, which means it's actually 93 divided by 1,000, right? Because if we go up 1 step, 2 step, 3 steps, this is 10, 100, 1,000, right? 93 over 1,000, that's going to be, we're going to move it once, twice, thrice, so it's going to be 0.093 DAM. Okay, so that one was a little bit of a twist because it was metric to metric instead of metric to imperial or vice versa. But as you see from here, it's nothing all that different than any of the stuff that you've been doing so far, right? So Ashley, that was everything I wanted to cover then for Math 1102A Unit 2. Hope that helped you out a little bit. Brittany, I'm going to swap over there now to Prism Math Purple right after I mute the stream for about 20 seconds for a dire emergency. Okay, crisis averted. We're back. Back Twitch chat. We're doing it live. So let's bring up something nice for a second. Let's see. So you asked about 243, 244. I don't appear to have. Let's see. I think you might have already gotten a good solution to 243 there, Brittany. Tell you what, I'll just write out the one on 243 because I don't appear to have taken a picture of it. So I'll leave the little doggies up there in the corner for a brief moment. Okay. So this is Prism Math Perp. This is page 243. And I believe you asked about question, well, you asked about question 10 and 11. But both those are fairly straightforward, right? I do think that it's only because it's written out in words that there is any problem. Because what it says is 3 members of the debate team left, 3 members left the debate team during the year, okay? So if 12 members remained, how many were on the team originally? Okay, but even if you can't write it out in the algebra from what's there, just logically think about what the situation is, right? Kind of try to think through what they're talking about. If 3 people left the team and now there's 12, there had to be more than 12 originally, right? So if 3 people left the team, so there was some number of people on the team. 3 people left it, and then afterwards they had 12. Now you probably already know from just reading the question and thinking through the situation that if 3 people left and there's 12 now, there had to be 15 at the start, right? So you know that if you do out some algebra and you end up getting anything other than n equals 15, well, that's a sign that you did your algebra wrong, right? Because algebra, all it's doing is representing a real world situation in sort of math symbols, right? So if you end up, oh, my chair is eating my headphone cord. So if you end up in a situation where the algebra that you do doesn't match sort of what the situation would really be, then that's, it's a sign that maybe you should check the work that you did, right? And again, like I'm not saying anything specific about about what you're doing, but as you've noticed in general, I do talk a lot about ways that you can check your work, especially on a test or in any situation like that where you need to check it and can't necessarily ask the teacher. So let's zoom this in, zoom this down. So write the operation that would undo the operation. Now these ones are fairly similar. I believe yes, I did indeed actually go over these exact ones on stream the other day, and I believe I linked you to those. I will very quickly go over a few of these again as well. All right, but I'll go over these first three, and then I'm going to do some of the solve each equation that are down just below. Right, and I can see your messages there in chat, so if any of these are ones that you don't need me to cover, you can just drop in chat and tell me, and I'll switch to other ones. So 6 times a equals 24. The idea here is that we have to get a by itself, because a is the variable. So we got to get rid of this times 6 that's here. Got to get rid of that guy. How do we get rid of it? Well, we do the opposite, right? So kind of what we're doing is the same thing to both sides, but for now, we can think about it as this 6 is actually moving over to here, and it's just turning into the opposite operation, right? So it's going to be a is equal to 24 divided by 6. So a is going to equal 4, just like that. Okay. For question 2 then, right, we're going to have 4 is equal to n divided by 3. Well, some number n divided by 3 gives us 4. So you might already be able to figure it out from that sort of hint, right? But here, what we're going to do is we're going to do the opposite. So we had to divide by 3 on the right. So to get rid of it, we're going to end up multiplying by 3 on the left, because that's the opposite of what it was previously. 4 times 3 is n, or 12 is equal to n. Right? Same sort of deal with question 3 here. We have x times 8 is equal to 56. So we're going to have to divide both sides by 8 to get rid of this 8. We're going to have x is equal to 56 divided by 8, or x is equal to 7. Right? So that's a good example of how we start off on page 244. Like I said, I'm not going to do an example of, I'm not going to do every single question on here, but these ones are decent examples. And you have asked me to go on to ones that are a bit trickier. So I'll do a few more here, just so you get an idea of how the rest of these ones are handled. But then I'm going to move on to the two-step equations, which start on the next page in Prism Math. So let's do question 4 then. You understand, if you have time, you do example on page 248. I might be able to do one on there. Now, where I only have the teacher's copy, I'm not going to be able to show any on stream from that book without first taking it and editing it down. Right? So then we black out the ones over on the side. But I will jump over, let's see, I'll skip past 244 then. Let's bounce over to 245. I'll do a few on this page as well, because I believe there were some questions here. And then 246, I believe you had some questions as well. So I have those ones prepped and ready to go. So how's about, I'll do the first few on this one, and then the first few on the next one. Then I'll see if I can wedge in some from 248, I believe you asked. So this is now going to be page, what is this, 245? Yes, page 245. I'm going to do, yeah, I'll just do questions 1A, 2A, and 3A, I guess. Well, maybe I won't do 2A. Maybe I'll do, yeah, I'll do 1A and 3A. Okay, so 1A is 2x plus 5 equals 11. Now, the thing is here, we have multiple steps here. This is what we call a two-step equation, right? So these guys up here were one-step equations. So this row, we can call these all one-step equations. EQTNS, I'll just use that as an abbreviation, one-step equations. But these ones down here are two-step equations because there's multiple things that you're doing. Now, I recommend, in general, kind of working backwards from bed mass here. You know, the bed mass tells us the order of operations. Here, generally, I recommend trying to get rid of your addition and subtraction first, because now we're solving. We can think of it as we're moving backwards across bed mass, right? Excuse me. So this 5 is going to end up over here. 2x equals 11 minus 5, or just 2x equals 6. Now we've got a one-step equation, same as we had up here. We can go ahead and divide. X equals 6 over 2, or x is equal to 3. Right? This is super important stuff. This is really core to every course. Every single math course you do past this point is going to involve two-step equations or equations with quite a lot more steps, right? So this is some of the best fundamentals that you're being introduced to in these refresher courses. Right, so 3a, let's go ahead and do that one. 3a is n divided by 6 plus 12 is equal to 15. So again then, I'm going to work backwards in bed mass, and I'm going to get rid of my addition or subtraction first. In this case, I've got an addition here that I'm going to get rid of. So n over 6 is equal to 15 minus 12, or n over 6 is equal to 3. And of course, over is just a way that I'm reading divide by. Plenty of teachers or profs or whatever will just read that as n over 6 instead of n divided by 6. But it does mean divided by. So to get rid of this divide by 6, I got to multiply by 6. So n equals 3 times 6. N equals 18. There we go. Good stuff, right? Sorted. And while I'm at it, seeing these are quick, I'll do 7a as well. 7a, we've got n over 9 minus 9 equals 0. Right? So we're going to move this 9 over. It's going to become a plus 9 because the opposite of minus 9 is plus 9. But we're doing 0 plus 9. Does that work fine? Of course it does. Of course it does. You can add things to 0 just fine. N over 9 is equal to 9. So now I've got to multiply by it. We're going to have n equals 9 times 9. N equals 81. Right? Okay. Yeah, it's good stuff. Sailing through these ones. But Brittany, if you have any issues with any of these ones as I'm going, you can drop a note in chat to stop me. I'm going to carry on and do a few off of page 246, which you asked for, and then I'll take a quick look at 248, see if I can't just write a few out onto paper to solve. Let's see here. So you did ask for some of these ones. It's pretty straightforward. Yeah, I think so. That's great. I mean, this stuff, ideally, this stuff does seem straightforward. And it's one, I've said it a dozen times, one of the nice things about Prism Math is they drill you a fair bit on just the absolute basics of the algebra and the arithmetic and stuff. So yeah, all the pieces are individually really straightforward, and that's great because later on other courses are going to assume that you already have a really good grasp of this stuff. So it's important to get it now, right? That's great. If you understand these kind of things, this is essential basics of math. I know this one looks a little bit different, right? But one reason I did want to go over this one on stream is because when you're dividing by a phrase, you're dividing by an expression here. You're not just dividing by one number. It's not only a phrase, it's my English teacher is showing. When you're dividing by an expression like this, right, you can actually treat it as if the entire denominator here is in a bracket. You can totally treat it like that because what they're actually doing here is this is not a fully simplified question. It's a bit weird because here they've given us the one that's simplified as far as they can go, and here this one's simplified, and here this one's simplified. But here now, they've actually given us one that needs to be simplified first. So if you look over here, back over to my cursor, it says solve each equation as the directions. It should be simplify, then solve each equation is honestly what it should say, because they're giving us questions that are not fully simplified yet. So first up, we have to go ahead and simplify as much as we can. Well, what is 15 minus 8? 15 minus 8 is just 7. So n over 7 plus 31 equals 45 is what we have. And now all of a sudden, it looks very similar to, say, this guy up here. Right? So I'm going to solve it exactly the same way. N over 7 is going to equal 45 minus 31, and divide by 7 is equal to 14. So then I'm just going to move up because I'm running out of paper. N is equal to 14 times 7. So n is going to be equal, what's that? 70 plus 28 should be 98. 14 times 7, 98, yeah. So there we go. N equals 98. And that was 1A on 246. Let me do, oh, thanks. I'm not sure how to read the, I'm not sure how to read those emotes, but you're very welcome. Okay, let's pick another. Let's see. Are there any ones here with any other sort of? No, these ones here are all relatively straightforward, aren't they? Compared to what we just had. Let me see if there's any with any like any twists in them. Not really. I'll do one other one. I'll do 8B. To do one other example of this sort of math. 8B here is this guy. It's the 85 minus 67 is equal to 9 plus W over 14. Right? So here now we can go ahead and we can simplify this side. 85 minus 60 will be 25. 25 minus 7 will be 18. So this is 18 equals 9 plus W over 14. Now, one reason I wanted to show you this one is because, well, what the heck? This 9 doesn't have an add or subtract in front of it. Now, I want to move the 9 to get rid of it. How do I do that? Yeah, it was the weird fractions. Yeah, but all you have to do then is know that you have to simplify it first, right? So it's just 15 minus 8. We'll just turn it into 7, right? So over here now, there is a situation where we've got a 9 and there's nothing in front of it. Well, what do? Well, we treat it as if it was a plus, right? Because a number, an integer, with no sign in front is positive. So this is actually a plus 9. So when it moves to the other side, it's going to be minus. So we have 9 equals W over 14. So 9 times 14 equals W. And that's going to move up here. And it's going to be 140, because that would be 14 times 10. 140 minus 14, which is the same as 130 minus 4, which is 126. There we go. I always like to talk through my mental math, right? Modeling. Good modeling how you do good mental math is essential. That's one of the reasons my that grade 6 class, the top set grade 6 I taught in the UK, was doing mental math faster than the teacher after a little while in. Okay, so that was mostly it. I'm going to, yes, I will check now, Brittany, and see about the next page that you asked for, 248. I'll see if I can get a question or two off of that, and I'll return you to the capable care of little Flurry and Smokey up in the corner there. Oh, 248. The number lines. Graphing inequalities on number lines. Oh, okay. Okay, sure. This is like a totally different topic, but it's not really that difficult. It would be a little bit easier for me to write it out if I had a picture of the page, but let me just do Prism Math purple. I can still cover this a bit. This is going to be page 248. Okay, so graph inequalities on number lines. Well, I'll tell you what, I'm going to draw one big one, one big number line, and then we're going to graph a whole bunch of the inequalities on the same line. Okay, so I'm going to make a good show of this one. Make a big honker over here. And then say I'm even going to measure these, every ½ centimeter, I'm going to put another notch. If you're not, have I got any bald spots, Twitch? Are you seeing? Are you seeing my nice DIY haircut, Twitch? You like that? You like that? Look, it's pretty good. Hey, it was done with my beard trimmer. I don't know if I should be proud of that or not, but after social distancing started, my hair was already quite long. I already looked like I was sort of displaced from a glam rock band. You know, not quite that bad. Anyway, so those are all evenly spaced, is what I was going for. Now let's see, what values do we have? Do we have any negative values on this sheet? No, we don't. Okay, it just so happens that this sheet doesn't have any negatives, but guess what? I'll show you ones that have some negatives as well. All right, so I'm going to say, I'm just going to arbitrarily pick this one to be 0. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got a lot. 23, 24, 25, 26. Okay, so this is just showing you how a number line goes. It's just a line with numbers on it. Boy, it's right there in the name, isn't it? Number line. Hey, what's involved in a number line? Lines and numbers. Okay, and we go, so we're going from -10 all the way up to +26 on this number line. And I'll put another arrow here. I know it seems a little bit pedantic. Now to graph numbers but not letters. Well, but the letters stand in for numbers, the same as they have in every other thing that we've done, right? Because in algebra, a letter is just a stand-in for a number that you don't know yet. So if you know how to graph the numbers, graphing the letters should be fine. So say then for A, here we're graphing inequalities, right? So this is 246 part A. So here we're saying D is greater than 3. Okay? How are we going to graph greater than 3? What values are greater than 3? Well, I'm going to have them done out sort of down below here, right? I'm not going to, normally you would draw them on top of the line, but to prevent myself from having to draw out a whole bunch of different number lines, I'm going to draw it down below, right? So D is greater than 3. So number 3, we know is the number that we're going to start with, but it's greater than, not greater than or equal to. So if it's greater than 3, we use a hollow circle. We use a hollow circle over the 3, and then I'm going to, just let me turn my page for a second so I can reorient this a little bit better for myself. We're going to go that way, right? So like this. So this is question A. That's how you would draw it, right? So like I said, normally you would write this over your number line, like on top of it, but to stop myself from having to draw out another number line for every single question here, I'm going to do mine below. But for A, D is greater than 3. So this shows all the numbers that are greater than 3. We start at 3, but it's hollow because it's greater than, and then we just keep on going up. So say 1B. So this is 1A, right? So let's say I do 1B. 1B is that Y is less than or equal to 8. Okay? Well, now I go and I find 8 on my number line. Where is 8 here? Well, 8 is right over here. So again, right, normally you would do this on top, just superimposed over it, but you know, I'm not going to do that for now. And now it's Y is less than or equal to 8. So Y can be 8, so we use a solid dot. and now y is less than 8, so y is actually going to go in this direction. It's going to go down, right? Because the numbers in that direction are the numbers that are less than or equal to 8. So this one here now is 1b, which is y is less than or equal to 8. This green one here was b is greater than 3. Right? So yeah, so that's good for that one, I think. I'm not going to touch the rest of numbers 2 and 3. I will go ahead and do question 4, because question 4 has a bit of a wrinkle. Okay? You're very welcome. I'm just going to carry on and finish question 4 there. So question 4 is a minus 3 is less than or equal to 5. Because another important thing to know is that an inequality like this, you can do the algebra around it the same as you would if it was an equal sign. Like as far as the algebra is concerned, you can just move stuff around it the same as ever. So we're going to have a is greater than or equal to 5 plus 3, because like we saw on the previous page, when it moves over to the right, it's going to become a plus. So a is greater than or equal to 8. So that's going to be pretty similar to the y one down here, because y was less than or equal to 8. So we're going to start at the same point, but now we're going to go up. And go in this direction. So this is 4a down here, and that's a is greater than or equal to 8. So then if I was to go ahead and do also say, oh, that was 4a. Now let's do 4b. Let's keep switching up my different color inks. I'm going to need to invest in some different colors. What are some different colors, Twitch chat? I'm a computer nerd. I only know RGB. I don't know none of the cyan, yellow, magenta nonsense. So if it's equal, do I draw a line over the full graph? What do you mean by equal? There's never going to be a full graph because a number line goes on infinitely, right? Like if I wanted to keep going, I'd go past 26 to 27, 28, 29, 30. What you're always going to do is circle the number if it's not equal to, or put a solid dot if it is equal to, and then you're going to color either the direction up or the direction down. So then, for example, 4b is g plus 11 is less than 20. 3, so 3 equals equal. 3 equals 3 is just a solid dot. You don't have, Brittany, there's none on this page that say that. There's nothing on this page that says 3 equals 3. If you're looking forward at other pages where they just tell you to put a dot at 3, you just kind of go to 3 and then you put just one dot there, yeah. But that would be a different sort of situation than what we're showing on this page. So this is going to be G is less than 20 minus 11, or G is less than 9. All right, so here now we're going to go to 9. We're going to put a hollow dot because it's less than, and then we're going to go down. Now again, please, I think one of the things you might be, don't get confused about how I'm drawing this below. Normally we would write it on top. So that is 4b. So you're going to have one direction or the other that you have to go in, say for these ones. And if you're just naming a point on a number line, like say 249, you just had to name a point. Well, say for example, I asked you to name point A on, actually no, I won't use A because A is one of the ones we've just done. Name point R on the number line, right? This is the kind of things you had to do on the next page. Say point R was over here. They're like that. It would just be R equals 22. There you go. That's all you got to do because R is over here, right? Or say if we had to name point point K, right? Point K on the number line could be this one here. So we just say K is equal to -5. Right? And that's just a bit of an example of page 249 on that side. Okay? All right, great. I think that is everything that I needed to get to today. Yeah, thanks for coming out and watching the stream, everybody. Hope that it's been helpful. You know, glad to be offering this service, and I hope that people are finding it useful as you continue your education. Yeah, thanks very much for being here for another day. I will remind you guys now, of course, that we are off on Friday and we're off on all of next week. So I'm not going to have any stream on Friday. Um, Next week, maybe I'll randomly pop in a few days next week for some recreational streams. Maybe not. I don't know. But there's not going to be anything official. No math streams next week because it is Easter holidays for us, and yeah, there's been a lot of uproar recently, so I'm sure a bit of a holiday would do people good, right? Don't forget to wash your hands. Yes, don't forget to wash your hands. I don't know about the Gossip Girl part. I don't know. I don't know. I'm not. Is that some sort of meme? You just end messages with the phrase Gossip Girl? I don't know. Am I missing out on the trendy new memeology? But yes, do please wash your hands. Do the sing a little 20-second song to yourself when you're washing your hands, so you know how long it'll go for. And make sure to get the backs. Make sure to get a good. That's what I'll do. Maybe I'll do a hand washing stream. Yeah, yeah, that's good. Mm, just 20 minutes of me just washing my hands until like I don't know, boy. Anyway, thanks for being here, folks, and yeah, stay safe and see you again tomorrow.